Hello everyone. In this video, we are going to be discussing about the association rules, that is the last topic of our series. So let's get started. First, what is association? So association, we can understand it simply as a connection or link. And association rules are the rules that we try to decipher the connection or association between variables in the form of if antecedent then consequent. Now what does antecedent and consequent means is antecedent is the data set or feature that is present, and consequent is the data set or feature that we are trying to seek association of with the antecedent. So association rule is a statement that explains the relationship between two set of items. In case of dimensionality, the number of association rules grow exponentially in number of attributes. So basically, association rules are applied to the whole data set, and we try to find the best fit association rule and see how it works in our data set. In case of dimensionality, that means if we have a very large data set, that means that the number of association rules will be also very large. Now let us discuss about the support and confidence, which are the two measures that are used to calculate the effectiveness of the association rule. The support tells us how often a particular combination of antecedent and consequent is there in our data set, and confidence is basically the accuracy of our association rule. We have two more terms that we need to discuss, that is confidence difference and confidence quotient. So confidence difference is basically the measure of our association rule when it is compared to the average confidence of all rules. Difference, as the name suggests, we are trying to find a difference between our association rule and all the association rules average the present in our data set. Confidence quotient is the ratio that compares the confidence of a specific rule to the average confidence of the rules. So if we have association rules in our data set, then we have some confidence associated with it. So the confidence quotient is basically we are trying to compare the confidence of one association rule with the average of all the association rules present in our data set. Now we are going to see the code here. As we can see, I have imported the necessary libraries. From MLX10, I am going to call the pre-processing module and import transaction encoder, and from MLX10 to also call the frequent patterns module and import the a priori and association rules functions, which are basically the key functions here we are going to be applying in the Python code for the association rule. I have a data set, that is we are preparing a data set taken from the book only, that is transactions, that means what customer bought in transaction. The transactions here means the group of items, all the set of vegetables that a customer had bought and many customers have bought, we have just arranged them into a transaction data set. Then moving forward, we are going to convert the transactions into one-hot encoding. Now what is one-hot encoding? It is basically we are trying to convert our data set into a binary format. Why? Because we are going to use a priori algorithm, and a priori algorithm needs to have the binary formatted data, and that's why we are using the transaction encoder to convert our data into one-hot encoding. See, here we have transformed our transactions, we have fitted our transaction data here and returned the data frame that has the one-hot encoding into DF. Now we are going to find frequent item sets using the a priori algorithm. Basically we are applying the a priori algorithm here, and then we generate the association rules using the output returned from the a priori algorithm. Here I have also calculated the confidence difference and confidence quotient. This can be calculated by using this syntax. Here first we calculate the average confidence of the rules present in our confidence column and find its mean, and then we apply the confidence difference and confidence quotient. See, difference means we are going to subtract, and quotient means we are going to divide. That is the simple rule. And then we are going to print the results here. Let us see how it works. See, this is our frequent item sets. That means all the item sets mean all the features and all the vegetables that are present in our transactions, and we have calculated their support. We have calculated their association rules. That means if asparagus is there, then what is the consequence of squash to be present in our transaction, and its support is 0.285714. The same way it has calculated for every other transactions. Here we also have the consequent support and confidence. And here we have the updated association rules with confidence difference and quotient criteria. Basically, the confidence difference and quotient difference is used as criteria in association rules to find suitable and effective association rule in our dataset or transactions. So that's all for today's video. Thank you.